thanks for the organizers for letting me talk and for organizing what seems to be a wonderful conference. Yeah, so I'll talk about scientific theories of consciousness, the closure of the current physical and collapse. So this is joint work with Johannes. So my talk will have 3 parts, as kind of the title indicates. So the first part, I'll kind of talk about what I think should be scientific theory, well, the structure of scientific theories of consciousness. So these will be some kind of methodological aspects of how they should look like. The second part will be kind of how to define the non-closure of the current physical, and what does it imply for theories of consciousness. And then in the third part, I'll kind of give you a class of theories of consciousness based on quantum collapse model. There'll be another talk in the conference by Stuart, which will also give a theory which is quite close to what I'll be talking about, not exactly the same, but very excited to hear that too. So just kind of to say, really what I'm trying to maybe try and convince you, or kind of make you think about the possibility that it's very plausible that kind of the only possible theory of consciousness, scientific theory of consciousness, I mean, that if, let's say it like this, if there is a scientific theory of consciousness, we'll discuss the possibility that maybe there isn't, or there couldn't be, it will kind of, if there is, it sort of must involve kind of quantum collapse. But it's kind of forced on you from considering the possibility. So it's kind of like coming, you know, I'll show the first part of the talk to this methodological arguments, kind of try to explain why if you're trying to have a scientific theory, then there's not too much place to do if you're not kind of, if you're trying in a certain way, there's very little place to find it. And then the second part of the talk will essentially show, well, if your consciousness does something to the physical, then actually it has to be a collapse theory. So that's something you can prove as a mathematical theorem. And then the third part will just give you some examples of how such theories can look like. So I'm not sure I'll be able to convince all of you, but perhaps to kind of have some question marks that maybe quantum collapse is much more important than you might think. So let's kind of start thinking how does a scientific theory of consciousness look like? So I essentially say that kind of a theory of consciousness, we need kind of 2 ingredients. So one is kind of a definition, sort of what is consciousness? And I think what we've seen in the past maybe 10, 20 years is, which is great, is kind of many definitions. So kind of we have lots of definitions of what is consciousness, and which are kind of very interesting definitions. But the point is that definition is not enough. I mean, in some ways, kind of, if you think about it, there's, from a mathematical perspective, you can give infinitely many definitions. The question is, I mean, that's not enough for doing science. The next part we need is what I call kind of interaction. So it's not just kind of what is consciousness, but what does consciousness do? Or how does consciousness interact with other parts of nature? And by that, I mean kind of as defined by physics, chemistry, biology. So we need kind of something that tells us not just, well, here we define what consciousness is, we need some part, another part of the theory to tell us, well, here's how we defined it, and this is what it does. So one thing kind of to note is that, and you'll see that kind of in the last part of the talk with the kind of models I'll introduce, is that often kind of the definition can be implied by the interaction, right? So definitions can be of kind of a functional nature. So if I tell you what kind of consciousness does, it might be actually the definition of what it is. So that's a possibility. And I think it's kind of very important to emphasize that, well, without and this you might not agree with me, but I would say that if you don't answer the interaction question, if you don't kind of say what consciousness does, you cannot really have a scientific theory. Essentially because scientific theories need to be testable, they need to be falsifiable. If consciousness doesn't do anything, then there's just no way of testing what your definition. The definition you need to say some kind of, I think often I heard this, people compare, for instance, consciousness somehow to the discovery of heat, or not discovery, but definition of heat or temperature. I mean, if you just define, the temperature and then say that, for instance, I don't know, the conductivity of metal changes with temperature, and then you can actually do an experiment with two quantities that you can measure and see how they're correlated or related, you wouldn't have any way of ever testing what temperature is. It would just be a definition there somewhere in the air, and there would be no science you can do with it. So in the same way, kind of, we need to know what consciousness does. And I think if there's something really that you can take from this talk, and even if you don't buy my arguments about quantum collapse or anything like that, I think that maybe that's the most important thing I want to kind of convey, that we really need to start focusing on understanding what consciousness does, not just defining what it is. And I should kind of, definitely there's a very good formalization of this argument in this paper of Kleiner and Howe called falsification and consciousness. So that's one kind of, they give a good way of seeing this type of argument. I mean, they don't use exactly these words, but kind of why the theory of consciousness needs to say what consciousness does in a very precise way in this paper. So I really recommend looking at this paper if you haven't yet. So if that's what we're looking for a definition and an interaction, what are the possibilities of getting something like that? I'm not saying that I'll kind of list some modeling approaches. I'm not saying that these are all, but these are kind of the ones that come to mind, at least in my mind. So one possibility that I think we'll hear about later this week is something you might call idealist modeling. So essentially you can take essentially consciousness to be everything. You can take consciousness to be the only fundamental substance and replace kind of matter energy by consciousness. It's a possibility. So you can then try, say that consciousness is what there is, or conscious agents, and then kind of how they interact and so on. Now, the thing with this type of modeling is that, well, if you wanted to relate to kind of the science we have now, physics, chemistry, biology, well, you need to show how current physics emerges from such a theory. Now, which again might be possible, but it's difficult. I mean, clearly, kind of, if you want some kind of fundamental theory that just involves consciousness and somehow everything we know in science kind of emerges from that, that's possible but difficult to do. So maybe that's something that will happen in the far future, but it's interesting to try and model this, but it's difficult. Now, something which is kind of more closer to what we can do now is what you might call kind of emergent modeling. So, and this is very sketchy. One can go deeper into this, but you can decide on some set of systems, again, using the language of current science. So it can be brains or neural networks or whatever you think is where kind of you want to model consciousness. It could be just maybe human brains, so maybe your theory of consciousness would just apply for humans, or maybe just verbal humans, or I don't know. You need to choose some kind of systems that you can somehow is well defined in the language of science. And then you can define consciousness as some function from this set of systems to some other set M. So usually, maybe this would be a structured set. So it could be a vector space or a manifold. Like a good example of thinking of, like IIT, for instance, is an example of this. I mean, you have some set of systems, some type of networks, and to each network you can either define a scalar quantity like phi, or you can define a kind of a Q shape, which lies in some kind of more structured space, a higher dimensional space. And usually, this kind of consciousness, this function, it would usually be an emergent quantity. So by that I mean is that, of course, if you have some system, you can define consciousness. And if your systems are brains, you can say that consciousness is the state of a particular neuron. You can do that. I mean, that's a theory, but not so plausible. I mean, usually kind of this function will be some way of integrating kind of the state, the state of the entire system in a similar way that if we go back to this example with temperature, that from the perspective of sort of the system consisting of some molecules, and kind of temperature is some average property of this entire system. So this would be some kind of an emergent quantity. So that's the definition part. But now we need the interaction part, right? So how would an interaction part look like? Some kind of a functional relation, and I'm not specifying which one. It could be stochastic. There could be, imagine, lots of possibilities. But between your definition of consciousness, C, and some other quantities, x1, x2, which are, again, could be of a similar nature. So, but what we want is that these quantities are measurable in terms of current science. So now, so I should say, so these x1, x2, they could also be emergent quantities. So for instance, one example, you could relate maybe if your kind of set of systems is maybe human brains, and you define somehow what consciousness is for a given brain, and you measure the temperature of the brain, you might say that there is some relation between the levels of consciousness and the temperature of the brain. I'm not saying that this is a plausible theory, but that's an example. So some kind of a relationship could be a stochastic relationship, but some type of functional relation between some quantities. And this is kind of really what the theory, these are the predictions of the theory. This allows you to say that, given some levels of consciousness or some structure of consciousness, the system will behave in a certain way. And again, x1, x2, and so on, they could be also emergent properties. So it doesn't necessarily have to be properties like measuring the particular state of one or two neurons. It could be things like electrical conductivity or whatever you want to think about. And you need to make sure that kind of something about this modeling in terms of the interaction, just make sure that the theory is not implicitly tautological. So in principle, kind of this functional relation could essentially be a fancy way of writing that consciousness equal consciousness, right? Because consciousness, especially if it was defined in the start as some emergent property, you did some kind of complicated integration of the properties of the kind of elements of your system. You can do in a different way the same kind of get C or define C plus 1 by just doing a slightly different kind of integration of the elements of your system, and then your theory essentially just is tautological. So that's something to be careful about if you want your theory. In other words, you really want kind of a theory that this functional relation F is not just between two emergent properties that are essentially kind of defined completely as emergent things, and none of them is really, you can measure in terms of some other parts of physics or chemistry that we know. So you just end up with a theory that doesn't give you any predictions, except that it says that it's correct. So now I want to say that with this, in terms of, like I said, in terms of definition, that we can think of lots of definitions for C. But if you start thinking about how such a functional relation would look like, that becomes much harder. I mean, where could we find such a thing? So I won't say that it's not easy to come up with a plausible emergent model. And the main problem is kind of really about predictions. So what form should the functional relation F take? So in other words, kind of remember how I started the talk is kind of we want to say what consciousness is, but then what consciousness does. So if you think of some kind of emergent property of the system, you want to say, well, this thing does something if you kind of compare to the rest of physics or chemistry. And it's hard to exactly, if you start thinking about it, what do we, there are lots of kind of notions we like to think that maybe consciousness does, things related to free will or us being some kind of agents that, that we have some control over our thoughts, our emotions, and our movements. It's not very clear that, this is really what's going on. I mean, I know that it's very important for us culturally and also for our legal system that such things are true, but it's not very clear that scientifically we could really say that that's the case. So, yeah, do we know of any human animal behavior, physically measurable quantity that needs consciousness in order to explain it? I'm not saying that there isn't, but I'm saying that it's hard to find one if you think about it. And especially if you want to kind of apply Occam's razor, I mean, if you can explain human behaviors without mentioning consciousness, then maybe you wouldn't want to use it to explain these things. So, like for instance, just some funny. Suppose you want to kind of relate consciousness to some verbal reports. I mean, that's often what. How do we know that other people are conscious? Well, they tell us kind of, I feel this, I feel that. I mean, just this is a bit of a joke, but kind of recent experience with very simple neural networks shows that very complex verbal behavior might be explained without any or maybe very little consciousness. Right, so I'm referring to this thing that happened in Google with this system that I think is probably not conscious or has very little consciousness, let's say, but still can say about itself that I'm very conscious and I'm afraid, and maybe if you, do something to it, it will say, this is painful for me. And it's very possible, actually, what I think the message to take from this example is that it's very possible that we are very much the same, kind of that our verbal behavior is not something, in the Western kind of tradition, we're very intellectual and we like to think that the way we kind of speak and so on is something, a gift from the gods and it's something very special. It could be something really, really simple, that we're just trained enough as children and then later as adults in verbal behavior, and we can just say things, and some of them might sound very clever, but they're not kind of much more, well, they might be more complex than what this very simple neural network does, but not much more complex than that. So, if we can explain kind of human verbal behavior in this way, then it's not clear that we would need consciousness for this, or that even that this would be a good way of finding some functional relation, relating consciousness to something else. And I'm saying that if you start thinking about other options, that also might be the case, kind of the way we move, the way we feel. I mean, many of these things can probably be explained without mentioning consciousness once. Now, you might say, okay, but these are all, but still, I know if I'm conscious or not. So maybe the only way of kind of testing this theory or getting some kind of relation of this way is in the first person, right? So each one, will, or let's say each scientist interested in this will learn this theory and then test on themselves. And well, if the theory tells that I'm very conscious, I'll just see if this is true or not. Now, I would say this is very problematic for, how good is the average person scientist in determining the content of their own consciousness? And if I'm not saying we cannot get much better, and I think we should, and I would recommend meditation for all of you as a way of getting slightly better in kind of seeing the content of your mind. But, and by the way, if you do that, you might kind of find interesting things that go against what you might believe about your consciousness. But again, it's not clear that this is a good way of getting a theory, by letting everyone test it for themselves. And then, of course, all of this kind of, if you want, you know, this is again a big problem, kind of, from an evolutionary perspective. I think it should be quite clear that many animals have consciousness. I don't know how much, or maybe different levels. We really don't know. I mean, but the kind of things definitely verbal reports and so on would be a difficult. We don't know exactly how to extend such theories to other non-verbal animals or non-biological systems, right? So you see that there's kind of, with this emergent modeling, there are lots of problems. I mean, not so much problems in getting the definitions. I mean, you can define many things, but the problem of really getting any testable prediction out of them. I'm not saying it's impossible, I'm just saying it's difficult to really find one that is plausible. Which kind of, you know, leaves you, if you think about it in this way, is that it's very possible that consciousness is an epiphenomenon. Just which means that it doesn't have any interaction. I mean, it might be some kind of an emergent property that you can define in some way, but since it doesn't interact with anything, then there's just no scientific theory of it. I mean, you might have guessed the correct way it emerges, but there's no way you'll ever be able to test if your guess is right or wrong. So then we're back to kind of like, I don't know, thousands of years of arguing about what consciousness is. And, so that's kind of, it's definitely a live possibility, but there's just no scientific theory of consciousness. Now, another way is kind of what you might call new physics modeling. So this sounds kind of exciting, if that's possible. So find a new measurable quantity, so which interacts with matter energy and which might be defined as consciousness or awareness. So that, you know, this kind of tells you that really the way to model consciousness is by extending physics, I mean current physics. So, and then this, so you find something that you can really measure, some new quantity. Actually later give you an example of how this might look like. And now the thing is that, you know, this new measurable thing is maybe seems on the face of it kind of very different than what you might think of as consciousness, because it's defined maybe in terms of, you'll see later, of some measuring something that seems completely unrelated to what we think consciousness is, or what we think it does. So you need kind of to, if you find this kind of new physics, you need to check how this new quantity correlates with present-day notions of consciousness awareness. And you might find that there are some relationships, which might make you kind of more, you know, because of course the big question is always, okay, you found something new in physics, maybe it has nothing to do with consciousness. But maybe you find out that it does have something to do, but still, if it kind of explains enough, and somehow we start believing that, yeah, this new type of physics is related enough to what we think of as consciousness. It's just that, you know, we have very little idea what it is, and our cultural notions of what it is or does are not so good, but still these new things actually seem related. But we might need to change our ideas of what consciousness is and does. Because, so that could be kind of a future evolution of something like this. So that's kind of three modeling perspectives on scientific theory of consciousness. Now, so this kind of brings us to the non-closure of the current physical. So if you think about kind of the above considerations, I would say it is possible, and I would actually say likely, that a scientific theory of consciousness would involve new physics. Essentially because, again, I mean, okay, the idealist perspective is actually, you might call it new physics, but I wouldn't go there. I mean, we can go there and we'll have a talk, I think, related to that, but that's seems very difficult. From the emergent perspective, it seems, well, let's say I'm skeptical that it works, kind of in the sense of, at least if you're trying to kind of relate two emergent properties in any non-trivial way, or given any emergent kind of theory that would give you any predictions, that might be difficult. Because it seems like maybe we can explain all of our human or animal behavior without mentioning consciousness. So I would say it's likely that kind of we need some new physics in order to explain consciousness. So somehow, so it's still a physicalist approach. I mean, I'm not saying that kind of consciousness is something not physical. It's just that we need to extend current physics in order to see in what way, how to fit consciousness in physics. So this could be either in the form of some new interaction or some new entities in physics. And then the question is, okay, so that's a possibility, but could we say anything about this new physics? How would it look like? And the nice thing is that actually you can. So you can just, using some very basic assumptions and some maths, you can already see what type of new physics it could look like. So under some mild assumptions we can. So the slogan is that to leading order, I don't have time to go into the details, but I'll say a bit more. The new physics would be a quantum collapse model. So kind of what you can prove is that really, if in some sense consciousness does something, in the sense that it kind of changes, has some effect on our current physics, then the only possible way, at least to leading order, this has to be a theory of a quantum collapse. Now, here's something very important to note, because I think that's really what is very confusing about this statement. This is not saying that consciousness is necessarily quantum. Maybe it is, maybe it isn't, but kind of this statement is not saying that in order to define consciousness, you have to define it in a quantum way. It just says that, so it might still be some kind of an emergent property, something maybe like phi of IIT, so something that is defined purely kind of in terms of classical terms. It's just kind of that there's some interaction between this emergent property and the rest of physics. And we're assuming that this interaction is kind of does something, so it changes physics in some way. So in other words, the dynamics of the theory, after you integrate out consciousness, would be modeled to leading order by quantum collapse model. So this is what the statement means, because I think often kind of many people would say, well, consciousness cannot be quantum or something like that. Maybe they're right or wrong. We can discuss that, but this kind of this theorem definitely leaves the possibility that you can define consciousness purely in classical terms. It's just that kind of the way it interacts with the quantum part leads you to something that you can model by a collapse model. So here's kind of like a theorem. So to leading order in time, the induced stochastic evolution of any fundamental physical theory is a dynamical collapse model if and only if the theory gives corrections to the non-relativistic Schrödinger equation or evolution. So what this is telling is, again, something you can just prove from very basic assumptions, that suppose you have some kind of new underlying theory of physics, which, well, maybe I should tell you some of the assumptions here, and then I'll explain this more. So we assume kind of no faster than light signaling. That's kind of that's a reasonable assumption. And we assume that the physical states are described by quantum states, so kind of vectors in a Hilbert space. So we do have some kind of the machinery of quantum theory is there. We assume kind of that the induced time evolution of that there is an induced time evolution of the density matrix, so it's kind of some positivity assumption. Again, I would say a reasonable assumption. I don't have the time to go into details, and we do not assume kind of some Markovian evolution of the density matrix. So these are some kind of technical things, but I would say they're quite minimal assumptions on how such a theory would look like. So essentially kind of, and this is not just about consciousness. So it says that whenever you have some kind of reasonable extension of quantum theory, reasonable in the sense that kind of it satisfies these kind of assumptions, and then you try to integrate out, and by integrating out, you get some kind of stochastic evolution of the underlying kind of quantum state, then this stochastic evolution to first order in time would be what's called a quantum collapse model. So it kind of, just from very basic assumptions, you can see that any kind of extensions or deformation of quantum theory that are reasonable, the only possible extension is a quantum collapse theory. Of course, there might be kind of fundamental theories that are completely described in completely different ways, that have no Hilbert spaces, and quantum theory doesn't appear at all, and then this theorem doesn't apply. But if your theory is some kind of an extension of quantum theory, then it will satisfy this theorem. So when you go to kind of consciousness, here's a definition: a theory of consciousness describes the physical as closed if and only if it does not posit any changes to the trajectories of the underlying physical theory. So what this is kind of saying is, suppose we have the underlying physical theory, the states are described by some vectors in a Hilbert space, and then we extend this theory by some consciousness. There's something, and then we check kind of what happens, to the trajectories of the kind of what we now call physical, to these kind of quantum states. And we might find out that kind of in this new theory, and exactly if there is some kind of non-trivial interaction, these trajectories change. So this is a definition of kind of the non-closure of the physical in this sense. So a theory that does have this effect on the current physics will say that physics is not closed. And now you can see that that's kind of almost obvious from the definition, that the theory of consciousness describes the physical as closed if and only if it does not specify corrections to the Schrödinger evolution. That's almost the definition. And then the corollary from kind of the previous theorem is that to leading order in time, the induced stochastic evolution psi t of any theory of consciousness is a dynamical collapse model if and only if the theory does not describe the physical as closed. So in other words, this is what kind of I wanted to say, that if, well, we started kind of the talk by saying that it's hard to find places for kind of consciousness to do something in nature, in physics, right? It seems like in terms of human or animal behavior, we might be able to explain a lot of things without mentioning consciousness. Now, and then this kind of leaves us with the possibility that consciousness is an epiphenomena and just there's no scientific theory of it. Now, a way out is kind of say, well, consciousness does do something in nature, but it does it it interacts with some, it changes some of the quantum evolution. And if it does that, then you're kind of forced to, at least to leading order, you're forced to a collapse model. So kind of, it kind of constrains the space of how possible theories might look like. So I'll try kind of briefly, just 5 minutes, give you an example of such a thing. So this is about the measurement problem, collapse models in consciousness. So, well, quantum theory has two types of dynamics. There's unitary evolution and then projection due to measurement. And the measurement problem in quantum theory, sometimes called the Heisenberg cut, compared to the Schrödinger cat, is that's really the problem. How do you define measurement? It's not really a problem that we have two types of time evolution. The problem is that quantum theory takes as a kind of primitive notion measurement, and it doesn't define what it is. And I would say, if you look at it, that kind of if you know about interpretations and decoherence, they don't solve the problem. They don't define what measurement is. They still use it as some kind of a primitive notion. Now, this was kind of a theoretical discussion for many decades. Physicists mostly ignored it. But kind of, if you think about kind of with quantum computing and other kind of building bigger and bigger quantum systems, I think this will actually become, we need to solve this problem. So here's kind of one example. So if you want a quantum computer that runs, Shor's algorithm that can factorize integers, you need actually tens of millions of qubits. And you can ask yourself, well, now this is already not some small system, quantum system that we know is quantum. We can ask, does a part of a quantum computer, suppose maybe 20 million of these qubits, is in some sense a measuring device? Does it observe another part of the quantum computer and collapses it? Which kind of means that for, if we try to kind of really give a precise answer to what is a measuring device, we might find out that kind of quantum computers are impossible, or at least large-scale ones. You can have some kind of small quantum machines, but if you want to run Shor's algorithm, just physics tells you that's impossible. So here's kind of a toy model. It's really, there's a very nice paper by Pearl for collapse models. You start with some initial state, and the dynamics, it looks like this. So this is kind of, so here, BT is a Brownian motion, and satisfying some probability law. Unfortunately, I don't have enough time to talk too much about this. And notice here that there's a big kind of typo. That I was too happy to do copy and paste, so you should square everything here. So instead of 0.6, it should be 0.36. Instead of dividing by 4, it should be dividing by 2. Too happy with the copy-paste and not writing the correct equation. It doesn't matter so much. So I'll just tell you what kind of Pearl kind of describes this model. So BT, this kind of Brownian motion, it acts as a chooser. It chooses either one or the second eigenvalue to fluctuate around, and this determines the collapse outcome. So collapse models such as this provide an explanation for the random results which occur in nature and are unexplained by standard quantum theory. The result was this rather than that because the noise fluctuated this way rather than that way. What is left unexplained is at the next level. Why did the noise fluctuate this way rather than that way? A future theory may address this question by identifying the noise with something physical, for instance, gravitational fluctuations, and having dynamics to it. So, okay, I mean, it's really interesting kind of to see here that he describes this noise as a chooser, and it kind of makes a choice. So let's give the following definition. So let's define awareness as that which can observe quantum states, right? So I'm just, I said kind of as mathematicians, or, I mean, kind of definitions are cheap. So I just chose this definition, okay. But I like this definition because it definitely, this is the place in physics where we can say where there is something new happening. So this kind of uses the idea of consciousness collapses the wave function as a definition. You should know, there are kind of similar models, and there will be another, we'll hear the talk by Stuart, which is very much related but slightly different model. So yeah, I mean, in this kind of collapse models, the definition and interaction are the same, right? So I'm defining essentially what consciousness, or just call it awareness, because consciousness maybe contains lots of other things. So awareness is just defined by what it does. So that's how I define it. And if you look at kind of the toy model I showed before, we had this kind of stochastic field, and this was the one that kind of collapsed the wave function. So actually, BT is, you might call it the field of awareness, because this is what it does. And it has kind of free will in the sense that it's stochastic. So, and it's interesting that kind of this stochastic, it's necessary, I'll soon finish, it's necessary in order to prevent faster than light communication. And what's important is that this theory has different prediction to quantum theory, and also solves the measurement problem. So you can actually experiment with it, and experiments will actually indicate precisely what kind of properties BT has. So it doesn't have to just be a Brownian motion, it doesn't necessarily come from white noise, and it doesn't have to be Markovian. I mean, there are lots of kind of possibilities here. So it's a big class of models. And this is the final slide. So in more realistic models, this kind of continuous spontaneous localization, for instance, the stochastic field lives in space. So this is, and interacts with the quantum wave function. And its strength actually can be measured by the extra heat it produces. So it's a new physical quantity that can be measured. And experiments might show that this field is sensitive not just to, it might be sensitive to structural or information theoretic properties of matter, or if you want, the wave function. So, for instance, what this might tell you is that a quantum computer would collapse itself, but you can still have a superposition of large, unordered matter, right? Because it might be that the kind of, this field is sensitive to structure of matter, not just how much matter you have. So here's a possibility. Awareness is a space-filling stochastic field, which is stronger around ordered matter. Now, there are a large class of models that kind of we can construct that does that. And the nice thing about this approach is that instead of kind of a priori deciding, well, this is what consciousness is, actually experiments would tell you the properties of this field. I mean, by experimenting, you would see kind of what type of noise it is, and you know, is it Markovian, is it not, probably not. And just to finish, kind of from this perspective, it's very, you might end up with noticing that the strength of awareness field is not necessarily correlated with the complexity of experience. So it actually might be that, you know, we might think that you know, we have lots of thoughts and so on, and that's kind of, this is the thing that tells us that we're more conscious. And some theories like IIT kind of, essentially this is what you get out of them. But from this perspective, it might be that consciousness is something much more basic, and thoughts and so on are just some kind of computational things that awareness observes. It doesn't do them, it just observes them. And the strength of awareness has nothing to do with how complex you are. So it's not the case that kind of humans are much more conscious than I don't know, other animals, or maybe a thermostat. It's just that humans have much more computational power, but other kind of animals or non-biological systems are as aware as us from this perspective. I mean, that's a possibility. Yeah, and that's the end of my talk. Thank you.